True, Morgan. Yeah, it's a really important debate. Ricardo is all in on the hate. All right, I'm really glad that we're encouraging such important discussions during the Emerald Academy workshop. For those of you turning in on the YouTube, we're just discussing whether or not Nicki Minaj is the worst rapper of all time or not. Morgan here thinks that she's pretty incredible, and she's his idol, he said. But Ricardo says something quite different, actually, in the chat that I can't read on YouTube. All right. Um, so with that being said, welcome everyone. I think this is workshop 7 or something. I remember at the beginning of this boot camp, I was wondering whether or not this boot camp was going to take 2 weeks, 4 weeks, whatever. Anyways, turns out it took about 4 weeks, the same as the beginner one. Okay, good timing. And this is the 4th week, so yeah, workshop 7, and we're going to be talking about time in Cadence today, and we're also going to be talking about proving identity. So, pretty important stuff. Time is pretty easy to understand. Proving identity can be a little more difficult, but without further ado, let's get into it. So I'm going to start with actually the example I have here. Let's just copy this example. Oh, looks like I forgot a little initializer. Self.profiles. Oh yeah, for those, yeah, weird thing actually. When I write these examples, by the way, I literally just code them in here. I don't even code them in the playground. So that's why you probably discover so many errors in my code. Let me actually go ahead and fix this really quick. Um, and I really appreciate all of you that actually put these into a playground and say, "Hey, Jacob, they don't work," because it helps me edit them right here. But anyways, so what we're going to talk about today is how do you prove your identity in Cadence. This is very different from something like the Ethereum or Solidity world. It's very different, and I'll tell you why. It's because in Solidity, you don't actually write it like this, but let's say you write a contract like Hello World. What happens is when you call a contract, let's say you want to create, let's say you have like a list of profiles, right? Right here, you have a list of profiles. And then just pretend there's a variable there. And then down here, you have a function called like create profile with a name. And let's say this is like a certain name. Then let's say, actually, I'll write out the example. Let's say we have self.profiles equals an empty dictionary, and profiles is going to be a dictionary that maps a address to a string. So inside of this function, what you would do in the Solidity world is you would say, okay, the caller of this function is whoever is signing the transaction. So you would say the signer equals message.sender. This is something that exists in Solidity. And then you would say self.profiles at signer equals the name that we pass in. So of course this doesn't work in Cadence, but this works in Solidity. And in all the time that I've worked with Solidity and Cadence, I would say that this is the one feature of Cadence that I hate. It's that there's no such thing as like message.sender. Now they've purposefully architected Cadence to go away from this for many reasons, and there's actually an article that I think Deet wrote, one of the co-founders or he's I think the chief architect of Flow. He wrote a whole article about why they didn't include this in the Flow ecosystem. But this is one of the only features of Solidity that I wish we had in Cadence because it makes life so much easier. What we're going to do is we're going to go over a much more complicated example of how to do this in Flow. Now, of course, what you could do is you could say, okay, well, the signer, we're going to pass in as an argument. But what is the problem with doing this? What's the issue here? What can I do if we pass it as an argument? Morgan's got it. So you can pretend to be anybody. So yeah, you're exactly, Ricardo. That's what most of the article talks about. Um, so the problem is that if you pass it as an argument, then you can pretend to be anybody, right? I could call this function. I could pass in my name, but then I could pass in Ricardo's address, and we have this problem, right? So The question now becomes, in Cadence, how do we architect this solution a little differently so that, we make sure that it's us? So, does anyone think of something that I could pass in here that's very dangerous, but something I could pass in here that would prove ownership of the account? What type could I pass in right here? Secret key, true, but there's a specific type that basically acts as like a secret key. Yeah, I mean, well, Raven's got the idea. It's not exactly auth dot account. It's actually just called auth account. But there's actually an auth account type, right, in Cadence that you could pass in. And so in the transaction, you get the auth account in the prepare statement, and you could pass it through, right, which is, you could do right here, and then you could just say signer.address. Now this would work. I see Raven, you edited your message. You're a sneak. This would work, but this is basically like black magic in Cadence. You can do this, but anyone that like looks at this, anyone that looks at this would like immediately claim you're doing it wrong. There's almost like a secret, like it's almost like a known thing among Flow developers that you're not allowed to do this. So you shouldn't ever do this really. It's sort of like the black magic of Cadence is you should never be passing auth accounts around. So why though? I don't know. Well, I do know. I can give my own personal opinion. I think that encouraging people to pass around an auth account is extremely dangerous because that would encourage a certain behavior where, let's say users start to get a little more comfortable with passing their auth account around. What I could do is I could literally just update this contract at will and just say, you know what, withdraw all your flow token, and then some poor soul that thought it was fine to pass in their auth account with a snap of my fingers to get all their flow tokens withdrawn. So it's almost a standard among flow developers that we should always keep the auth account in the prepare statement of the transaction. Um, yeah, you said the transaction, but then you get into the argument of like, it's your responsibility as the developer to, to keep the users safe, right? You can't assume that users are going to understand what they're running. In fact, I would say more than 99% of users don't know anything about, Cadence code. And so as a developer, you almost, assume a responsibility to protect your users. And so because of that, you should never pass your auth account around to other parts of the transaction, especially because in Cadence, when you're running transactions through Blockdo or Lilyco, it shows you the transaction code, but it doesn't show you the contract code. And so, as a user, it's easy, or as a developer, it's easy to say to a user, "Hey, user, you don't have to know too much about Cadence code. However, if you see this one variable getting passed around, immediately decline the transaction," as opposed to saying, you know what, pull up the contract code, analyze it. If it's too much. So you shouldn't ever do this. So this is a no-no. Can't do that. So then what is the next? Yes, you could definitely grab the address in prepare, and you could say, you know what, let address be, or let signer be an address, and say self.signer equals account.address. And then down here, pass that address through. But then you run into the same problem because then you're going to architect your solution like this. And then it doesn't matter because I can still pass in anyone's address here. So it's the same thing. Okay, so with that being said, what's the next option? Well, then the next option is resources, and resources are our savior here. So what we can do instead is have a resource, call it anything, just whatever you want, and then we can put that function inside of the resource here. Okay. And when we do this, what's going to happen is we're going to keep the name here. But does anyone know, and Austin, you're not allowed to answer because you're already a wizard, how do I get the address of the owner of this resource? Does anyone know? I think Ricardo should know. One of my top Prodigy instructors. Yeah, so, well, not a, it's close, actually, Ricardo, close. close, but you have the right point, Ricardo. So it's actually self.owner.address. This will give you an optional type because with resources, it's possible that a resource isn't actually owned inside of an account. And by the way, when we say owned, we mean it's in account storage. So it's possible for a resource to not be in storage, right? Like if I just had like a public function test here, and I said let creator be create creator, and then I said creator dot create profile here and called this function, right? It called this function. At this point in time, self.owner.address would actually be nil. So this I'll show you this type. It's an address optional that we would get like this, right? So at this point in time, address would be nil because this isn't owned by anybody. However, what we're gonna do is we're going to make it so that we're going to actually make this a full address non-optional type. We're going to force unwrap the owner type here and put address, okay? And so now what we can do is we can say hello world dot profiles at address equals name. All right? And now we're good. Now we also have to add a function here called create creator. That's going to return a creator resource. And it's going to say return create creator. Boom. So we'll deploy this contract. All right. And then inside of a transaction, we're going to import hello world from account 2. And we're going to say I like to call this signer, or we're going to say signer.save hello world.create creator to /storage/creator. Okay. So we know that we've saved it here. And then what we're going to do, well, first of all, let's just run this function. So let's run it. Or the transaction, sorry. Okay, we ran it. So now that we know that the creator is saved in there, we're going to actually create a profile. And so now all that's left to do is to borrow that from storage. So let creator equals signer.borrow from /storage/creator. And we're borrowing a hello world.creator type. We know it exists, so we can unwrap it and then say creator.create profile, and we can pass in a name. So the name we'll say it's Austin, and we're going to run this from account 1. And it went through. And now if we were to actually read the profiles, let's go ahead and do that. And say this is a address to string mapping. We're going to return hello world.profiles. And we should see that we have Austin and account 1 address in here. So what we were able to do basically is prove our identity by saving a resource to storage, and then we know that self.owner.address will actually be the caller of this function, right? And what's cool, this is sort of like a random point, but what's kind of cool about this is that we could even link creator to the public, right? And even if creator is linked to the public and any user can call this function inside someone's creator, it doesn't matter because self.owner.address will still be the owner of the resource, not just the caller of the transaction. So that's actually a pattern I kind of use all the time. So Ricardo says, should you use a similar approach with that one as you do with minters, create and save one at contract and knit? What do you mean by that, Ricardo? What use case are you trying to solve with that? You should use a similar approach with that one to do with minters, create and save. Oh, are you saying to store a creator inside the contract and knit function? You could do that, but think about what we're trying to achieve here, right? This is different from a minter where we only want the contract owner to have a minter. Oh, I see. Okay, sorry. I guess I didn't do a good job explaining the use case. So with a minter, we only want the contract owner to have the minter, right? This example is a little different. In this example, we want everyone to be able to create their own profile. The question was more, how do we allow users to create their own profile while like ensuring that they're passing in their correct address and their correct name. So we wouldn't want to do that in the contract init function because, we want everyone to be able to do this, not the contract owner. And by doing this pattern, we're allowed to ensure, or we're allowed to guarantee that the user is creating a profile upon their own address, right? Because it's not possible for me to create a creator resource and then save it to your storage and then pass in my name, right? That's not possible. So this sort of solves that issue, and that's where this proving identity, comes into play. All right, sweet. So that's about it for this chapter. That's self.order.address. But again, I would encourage you to really think about a lot of different ways this can be used. What I mean by that is let's actually deploy this contract again. So let's deploy it again, right? Let's go back to creator. And what I'm going to do is I'm going to say signer.link, hello world.creator to the public, and then storage. So I'm going to link this to the public, which obviously, you wouldn't want to do because, then you could pass in your name. But I just want to show you what I mean by this. So this doesn't work that great in this example, but just follow me for a second. Let's save this to account 1. And then what I mean is that in a different transaction, we can actually, let's say we want to sign this from account 5, so a totally different account. I won't write it all out, but you can imagine that if we were to borrow account 1's creator here and call that function, it would still, self.owner.address would still be account 1, right? It's the person that owns the resource, not the caller of the transaction. That's another important point. Okay, so that's proving identity, and let's now go to day 2, which is time in Cadence. So in order to teach you all this one, I have to actually load up a terminal because time isn't supported on the playground. So let's load this up. So documents, I think I call it like YouTube test or something. Test.cdc. Okay. Remember we were doing storage iteration last time? I'm not sure because the playground uses the emulator, and by default the emulator doesn't support time, but that would be cool if they did support that. I also was wondering this morning, by the way, why they removed the link to the new playground. Okay, so we're gonna return a ufix64. So time and cadence is pretty easy actually, and I'm gonna show you that. So let's just increase this a little bit. So yeah, time and cadence is a pretty easy topic to understand, but let's just let's go with it. So do you all know Unix timestamps? So a Unix timestamp, I might not explain this the best way possible, but essentially a Unix timestamp, I don't know how you did that, Raven. That's pretty cool. Is the amount of seconds that has passed since January 1st, 1970. Ricardo, I'm sensing a bit of sarcasm. I'm assuming you've worked with these a lot. Yeah, so this is the amount of seconds that have passed since whatever. Now the point is that when you get time in Cadence, it is a Unix timestamp. So it's a Unix timestamp of the current block that you're running the script or the transaction in. So how you can get it is you can say let time. Yeah, it is quite a task, exactly. Is get current block dot timestamp. And this will return a ufix64, and then we can return time. Let's try this out. So let's say flow scripts execute dot slash scripts slash test dot cdc. Let's do this on mainnet. So boom, this is the Unix timestamp. Yes, in seconds of the current block on mainnet, right? Boom. So the reason I mention this is because one of the things you can do, and I'll write this in the playground actually, is you can say What are some of the things I want to do here? Um, let's say I don't know, this is like the stupidest possible example I can think of. Um, time of deploy. This is like the worst ever example, but it'll get the point across. Self.time of deploy equals get current block dot timestamp, right? So let's say you deploy a contract, and when the contract gets deployed, you set this variable to time of deploy to the time that this contract was deployed, and then you want to have a function called bin 30 seconds. I don't know. This is so dumb, but whatever, right? What you can do is say return self.time of deploy uh, plus 30 is greater than or equal to self.get current or sorry get current block that timestamp. Wait, 0. So yeah, so you can say when the contract gets deployed, you make this a little time. You set this timestamp, and then you have this function called bin 30 seconds that returns whether or not it's been 30 seconds since the time of deploy. So again, because this is a Unix timestamp in seconds, what you can do is say you add 30 to it because 30 seconds and see if that's greater than the current timestamp. And if it is, then it has been 30. Wait, is this even correct? No, it should be the other way around. Wait, I don't even know. Math. Oh god. Oh god. Math. Oh god. When you're presenting, it's impossible to think straight. Uh, am I an idiot? Wait, I can't think when I'm presenting. It's like too much pressure. I was right, right? Did I just like second guess myself? Okay. I wait, but is this definitely right though? Because what if this was like 10, right? And now it's what if let's say it was 10 and this is 40 and this is now 70. Then it's not right, right? Wait, am I having like a panic attack? Wait, because let's say this was 10 and this one is now 70. Then that's false because it's been 30 seconds, but 10 plus 40 is not greater than 70. Okay, yeah. I guess that's what I meant. Yeah. Okay. um yeah. Don't make fun of me. Okay, yeah, so that's timestamp. So I want to show you a real life example of this. Um of using time. Oh wait, no, it's actually OX2D. Yeah. Let's see if I can find a little example of this in the float contract. Oh, this is one. So we basically say, we mark the time that the user mints their float. So date received is the current timestamp, which is pretty cool. But I think there's also a start and end date. I don't know why that's. Let's check that out. There should be like a start and end time of a. Oh, it's in float verifiers. So you know how on the float platform, when you go to create an event, you can set a time limit. You can say, oh, it starts tomorrow and it ends in a week from then, right? These little things. What you do is, in the contract, you can pass in one of the verifiers here as a start date, and peace out, Austin. You have a start date, and you also have an end date, and we pass this verifier into the float event. And when you call verify, it verifies is the current timestamp greater than the start date. If it's not, then say it hasn't started yet. And if the end date is, or if the current time is, make sure that it's less than the end date. If it's not, then say, sorry, the time has run out to mint this float. So this is a perfect example of how you would use timestamps in Cadence, right? Boom. The only thing I would keep in mind is if you're planning on using this inside of a dApp, just make sure that you're taking into account the fact that the actual current Unix timestamp that you would get in like JavaScript, for example, reflects the real current timestamp, whereas this get current block.timestamp reflects the current time of the block that it's running in. So it's possible that it's off by a few seconds. To the real one, right? To the real world. So make sure to keep that in mind when you're displaying certain times, limits or on your front end. It can be a couple of seconds off. So just that's something to keep in mind. Actually, we might even be able to finish everything today. All right, yeah, let's keep going. Let's keep working through the stuff here. So, chapter 4, day 3 is called structuring transactions correctly. Now, this is something that you could completely ignore. It's not going to actually affect your Cadence coding. However, if you don't read this chapter and you don't learn anything from this, and I see you structuring your transactions incorrectly, I'll forever know that you suck as a Cadence coder. Is what it is. You'll just never be that good. So, something to keep in mind. So with that being said, let's take a look at a transaction that's not structured correctly at all. All right. This one. Well, you know what? That's. How do I get the errors? Okay. You know what? Let's get the errors out of here. Um, Fungible token. Oh, I forgot they also. Oh yeah, remember? You know how I always complained about metadata views because of the playground? Well, they also ruined fungible tokens, so that's great. Is flow token in here? Flow token. Let's put right here. Okay. Oh, I think we also have to, there's always this like error with the playground because you have to say self.account. Okay, and deploy that. Deploy. Something went wrong. What went wrong? A mystery. How frustrating. Um, okay. Well, maybe we can just ignore these errors. Maybe I'll just put it in here. Okay, this is better. Whatever. So just ignore the red lines. Sorry about that, but just ignore the red lines for now. Okay, so let's say we have this transaction, and the transaction borrows a flow vault from storage, and then it says to withdraw them and then deposit them inside the recipient's account. So this is cool and all, but we're not utilizing the differences between prepare and execute. So if you want to be a newbie coder, you can certainly do it like this, but there's a much better way to structure this. So what the prepare statement is for, and by the way, this goes all the way back to the beginner course. The purpose of the prepare statement is to access items in the account. And the purpose of the execute statement is to actually execute code. So what I would do is every time you run a transaction, I would utilize local variables more to actually structure these two things differently. So between this, but in all this code, what are the two things that we should be performing inside the prepare statement? Now, to remind you, this transaction borrows a flow vault, it withdraws something from that, and then borrows the recipient one and then deposits to that. So, what are the two? There's 4 lines here. What are the 2 lines that should go in prepare, and what are the 2 lines that should go in execute? Any guesses? Yeah, so the first one and the third one should go inside the prepare statement because they're accessing things inside of accounts. So what we can say is say let flow vault, and you have to give it a type. So this is the type. It's a reference to a flow vault. And then we can say let recipient. And for I don't know why, but I've always used capital letters for local variables here. Totally up to you, but I just think it looks kind of cool with capital things here. So boom, we borrow the vaults. Now what we can say is self.flowVault and borrow that. And then for this one, self.recipient vault. And then we're going to move the actual executing actions down to the execute phase. So the withdrawing and the depositing. So we'll say let tokens be self.flowVault.withdraw. And then we'll say self.recipientVault.deposit. So this is what a correctly structured transaction should look like, where you use the prepare statement to access things on the account, and you use the execute phase to actually do the items on those things that you borrowed. Now, sometimes people ask, well, can't this just be in the execute phase? It definitely could, because you don't need the signer or the auth account to access the public recipient. However, I think it's just always structured better when all the borrowing is done inside the prepare and the other stuff is done here. So, yeah, sort of a small thing, but I would say that it's definitely better this way. And this also really helps users build confidence in your transactions, because if they know anything about auth accounts, they'll be able to see, well, oh, the signer is only being used right here and it's not being passed around anywhere else. So it's impossible that I'm not like missing something, or it's not getting confused in a bunch of code, because you can imagine that when code gets more complicated, it's kind of hard to read, but when it's like this, it's a lot easier. And let's pull up like maybe even a little example of that. Um, I know Find on Flow has they have some good transactions to look at. Let's check it out. Transactions. Right. So you see here, for example, so Biarte is an amazing, obviously, right? So when you look here, this prepare statement's a little long, right? Which is fine. And users usually will open up the transaction, see, oh, there's a huge chunk of code. Well, what's sort of an issue with this, and again, it's not that big of an issue at all. So Bjarte, if you're watching this, no worries. I'm just using this as an example, but it's a little difficult here to understand exactly where the auth account is being used. Um, it's like, oh, it's being used here, and maybe it's being used here, and it's also being used here. But it's kind of hard. Like, maybe if this was like a malicious developer, which obviously they're not, but if it was a malicious developer, they could pass it into a random function, or they could maybe like hide a withdrawal of flow tokens somewhere. So it's not that great. Whereas if they had used the prepare statement just to borrow like maybe 2 things from storage, then you could confirm that the auth account's not moving anywhere else. Does that make sense to people in the chat here? Okay, yeah, cool. So always keep that in mind. All right, let's keep going to the very last day, and this is some miscellaneous stuff. So this is stuff I wanted to make sure you guys were aware of it. Honestly, I'm sure that most of you probably know all of this already because a lot of it's just like even stuff you'll find in JavaScript. But why not? So let's try it out. So one of the things I always find useful, and I also love this chapter because we can just play around in a script. Let's just start playing around here. Let's say you have a variable called var1 that equals nil, and you want to say you have another variable called var2. var2 equals 1 or something, and you want to, let's just say it equals like 0, and you want to say if var1 equals nil, then var2 equals 1, else otherwise var2 equals 2 or something like that, where you're setting the value of var2 based on the value of var1. So this is like a long way of writing it. A different way you could write it is literally just saying, oh, let var2 equals var1, otherwise some other value, if it's nil. So basically what this means is if var1 is equal to nil, then var2 will equal 1. Otherwise, it'll just set itself equal to var1. So this is just another way of using this little the double optional. The reason I say this is because when I was coding Cadence and I was still like a developer noob, I used to think that this double question mark was only used for like borrowing statements. So you know how you'll see often in transactions something like this, panic, hey there. I used to think it was only used like with panic all the time, but you can use it wherever you want to test a nil value. So you can say, you know what, if we're going to check to see if var1 is nil. If it is nil, then we'll go with this side. Otherwise, we'll just go with this side. So I don't know, random thing. Sometimes I use that. Dottie says, does Cadence have any static analysis tool that prevents developers to make code mistakes? No, I don't think they do. I don't think so. You mean to like check if like an auth account's being passed around? I don't think so. Yeah, I don't think that exists, Dottie, actually. We're trying to do that a little bit with Shield, our like Emerald City Shield service. We're trying to do that a little bit, but we haven't fully implemented that yet. So yeah, this would be used to say like this is instead of saying like if var1 equals nil, then var2 equals 1, else var2 equals. So this is the exact same thing as this, just shorter. Okay, so that's that. Next one is optional binding. So yeah, optional binding I would say is something I use all the time. Um, so let's give it a go. So optional binding is when you say, let's say we have var1. Let's say it's like an int optional value equals nil. What you can do is use a thing called optional binding, where you see if let var2 equals var1. Print or log var2, else log var1 is nil. So this is optional binding where you see if let. It's really helpful. Essentially what it means is you're saying if var1 is not nil, then set var2 equal to it and go inside of this if statement. Otherwise, if var1 is nil, then go inside the else statement. So you can see var1 is nil here. But if we set this equal to 10, we get 10. So it's a really efficient way of writing code. Now, this is usually a lot more helpful when you're borrowing things from storage. So I'll give you an example. Let's say that we have, let's say we have a I'm going to shorten this a lot. Like getting rid of literally everything. Okay. Let's say we have flow token here, and we have a pub resource vault. Okay. Like this. Very simple. And let's also have a function called create vault. Create vault. Okay. And let's say, yeah, so Ricardo, just like you're saying, this chapter is supposed to help you stop doing stuff like equals nil. Yeah, because there's a lot of other options for that. So now let's go in here and say, let's set up vault. So most of the time, if let's being used is with setup stuff. So let's import flow token from account 2, a transaction, and we have a prepare statement. Okay. What we're going to say is, sometimes with a setup transaction, what I'll write is I'll just say like signer.save, and then I'll say flow token.create vault, save it to /storage/flow vault, right? But sometimes this can be pretty bad because then you can't use this transaction again, right? Like for example, if I run this with account 1 right now and then run it again, it's going to give me an error, right? Because it already saves an object. What you can say instead is say, if actually, wait, this is a bad example. Shit. Oh, this is a good example. I didn't think enough. Yeah, I didn't think about that actually. Wait, that's a terrible example. You can just use an if statement here. Let's see if I use it in float at all. If let. Oh, I guess I use it here. So, sorry, I don't know why. That was a waste of time. Sorry about that, everyone. So I do use it here. Okay, so let's say an NFT resource represents a float, right? And the float itself contains a capability to the actual float event, so that you can read information about the event just from having the float, right? And so there's a function inside the NFT resource called getEventMetadata, and it will attempt to borrow this capability. So I use optional binding here because I say if let events equals self.eventsCap.borrow. So it's going to go to the events cap here and try to borrow it. So if I get inside of here, does this mean that the borrow was successful or that the borrow failed? Yeah, exactly, Falcon. So it's successful. So because self.eventsCap.borrow, and remember, when you use optional binding, you have to set it equal to an optional type. That's the whole point of optional binding is you set it equal to an optional. So self.eventsCap.borrow, and remember, borrowing returns an optional type. And if that optional is not nil, meaning it was successful, then we can go in here and the events is already unwrapped, which is another reason why optional binding is so helpful. It's because it sets it equal to an optional value, and if it's not if it's not nil, then it'll automatically unwrap it for you and give it to you as events. So then we can say events dot, and then we can call a function on it. Otherwise, we just return nil. Yeah, exactly. So that's like the main point of it is that it also unwraps it for you. So it's really helpful. So let's keep going and see if we can find another one. Oh, here's another great one. So in this case, what we're doing is we're indexing into a dictionary. Now, when we index into a dictionary, we all know that it returns an optional, right? When you do that. So self.extra metadata at prices, and remember, indexing into a dictionary gives you an optional. So if that value is not nil, it'll unwrap it for you and give it to you in prices. And now prices is a non-optional value, Otherwise, we just return nil. So that's why optional binding is super helpful. And if you want to check it out in the flow docs, there's also a video on this, no? Maybe, I don't know. Optional binding. There you go. You can check it out here if you want some more explanation on that. Sometimes I think things are easier just explained in text. Yeah, honestly, I just check out the text. It's better than me explaining it on voice. All right. So, yeah. Again, these are if you've coded before in other languages, these are really easy to tell. But when I started Cadence, I was a complete noob, so I try and keep that in mind for everyone. Um, so this is what's it called? Optional chaining. So this is something I use sometimes as well. Optional chaining is basically where, if we look here, so test one, all that a test is it has an ID in it. So in this case, we create a test struct, and we make it a test optional type just for the sake of the example. And here, number one, we say is equals test1.id. Now look at the error here. It's saying value of type test question mark has no member ID. Now, in order to fix this, you would have to either unwrap it, right? Because now it's fine. But the other point was that you can use what's called this little question mark thing. And if you put a question mark here, it'll basically say, you know what, we can get rid of the error, but this is going to return another optional. So ID is an int type. So in this case, this will return an int optional type. So it'll set number one either equal to nil. Like if test one is nil, then it'll just skip the rest of it and just give you nil. Or it'll actually access the value and just give you an integer. So that's the point of optional chaining. And you actually can see this a lot if you go to the Flovatar contract, or if you go to like any NFT contract, really, you'll always see optional chaining inside the deposit and withdrawal functions. So let's go to those two. Here. So look, here's an example of optional chaining, right? So we want to emit a withdraw event. So when we withdraw the NFT, we want to say, okay, we're going to pass in the ID of the token that's being withdrawn, and we also want to pass in the address of the person we're withdrawing from. So of course you could put self.owner force unwrap.address, but this will panic if the collection doesn't exist in the user's account. So sort of a weird example because it's very, very rare that you would ever withdraw from a collection resource that's not in someone's account. But anyways, in any case, you could just put self.owner question mark address. So this could pass in nil if this is not in someone's account storage, or it will actually pass in the address if owner is not nil. And you can see up top here actually that the withdraw event is expecting an address optional. So that's why optional chaining is working pretty well. And lastly, this is again something you would see in any programming language. But let's say we have this example. Let's say we have this example where var1 equals the string 1, var2 equals 0, and then we say if var1 equals 1, then we make var2 equal to something else if whatever. There's a much easier way to write this. Instead of having a bunch of if-else statements, you can use what's called a conditional ternary operator, I guess. And you can say var2, you can put a conditional, say var1 equals 1, question mark, which means, is this true? If so, then we give it 1. Otherwise, so this means if this is true, we give it 1. Then this means otherwise, and we give it another conditional. var1 equals 2, question mark, then we give it 2. Otherwise, give it 3. So this right here is the exact same thing as this, but much more condensed. So I'll walk you through it one more time. This says, if var1 equals 1, give it 1. Else, var1 equals 2, give it 2. Otherwise, give it 3. So if you want to, you can also use that. Falcon is right. Much harder to read, but, you know, I guess in cases like this, right? Let's say you have this, then I would definitely suggest using this example instead, because in my opinion, this is much easier to read than this. And the other, by the way, the other benefit of this as opposed to this is that if you use this example, then you actually have to set var2 equal to a default value. So you're actually performing more operations here, and it's again, even though gas doesn't really matter on flow, you're technically gonna spend more computation cost on this because you're setting it equal to a value and then changing it. Because in Cadence, there's no such thing as you can't just do this. You have to give it a value. Whereas in this case, you're just setting it all in one line. So yeah. And that's it. That's it. That's the intermediate course. Cadence capitalism. Yeah, exactly. So yeah, that's about everybody. Yeah, no, I actually much prefer this as well. Even though it is hard, I agree. Once you start getting to so many conditions, it's weird. But with this, I much prefer this. Yeah. Um. So yeah. So last but certainly not least is the assessment. So I'll paste this in the chat here. This is not something that we have to go over in a workshop. This is purely actually an exam for you to complete on your own. It covers pretty much everything in the course, at least all the really important stuff. So yeah, good luck. And I can't wait to see all of you fail. But yeah, congrats everybody for making it this far. Really proud of you, and to everyone in the chat here, thanks so much for entertaining me and coming during these workshops. Um, it's I love spending time with you guys in here. That's all I got. And I would say just the last thing. The only thing I would ask, it would mean a lot to me if you were to post some sort of tweet or something just saying that this course was helpful for you, if it was, or not, or whatever criticism. The only reason I ask that is because this course obviously isn't paid. I don't really get anything from this course. Um, and it's hard for me on my own to reach out and say, hey, this course was really helpful. So if you could, it would mean a lot to me if you could just send a tweet out and say that this course was helpful for people. That way people can, maybe, take this course as well. Yes, Daddy. All these courses are recorded on my YouTube. Let me actually show you my YouTube. I'm also going to stop the stream there. So if you